After all machining operations and several tests, our CTP crankshafts endure final scrutiny test and inspection from our well-experienced quality control team engineers. The equipment and tools used: solvent, lint-free towels, a compressed air source, inspection LED flashlight, outside micrometer, radius gauge, surface hardness tester, PMI or positive metal identification analyzer, dial indicator, pry bar, and torque wrench. We proceed with the cleaning of the crankshaft with solvent to remove any oil or solutions used during the machining process. The crankshaft is dried with compressed air, and all the oil passages are inspected for restrictions or any burrs. The crankshaft undergoes an overall visual inspection, checking for micro defects, porosities, and surface finish on each of the bearing journals to ensure there are no imperfections or scratches on any of the machined surfaces. Counterweights are inspected for casting flaws, burrs, or any imperfections. The crankshaft's main and rod journal diameters are measured with verified and calibrated micrometers to ensure that these dimensions meet the manufacturer's specifications and are well within CTP ISO 9001 quality standards. With a metal hardness tester, we proceed to check the hardness on each bearing surface. This is an extremely important process check. If the bearing surfaces do not meet the proper hardness, the lifetime of the crankshaft can be significantly reduced. With a handheld XRF PMI analyzer, we scan the metal of our crankshaft. This provides our engineers with a specific alloy analysis. The PMI, or Positive Material Identification Analyzer, accurately identifies alloy and metal composition of the casting material. With the help of a Romer CMM, or Coordinate Measuring Machine articulated arm, we accurately measure the spacing between each bearing surface wall with the next bearing surface wall. We measure the width of each journal, specifically the thrust bearing width. This ensures that the thrust bearing recommended clearance is within specification to reduce axial movement. To determine runout along the center, we place the crankshaft on V blocks, place a calibrated dial indicator gauge on our table, and lower the dial indicator's plunger until it rests on the top of the middle main bearing journal and slowly rotate the crankshaft. This will measure if there is any runout and that it does not exceed manufacturer's specifications. To check for axial displacement, we first install the engine main and thrust bearings on the block and carefully lower the crankshaft into place. We install the number 1 and number 6 main cap, and with a torque wrench, we tighten these down. Please refer to our crankshaft bearings assembly video for the proper installation of the crankshaft. With a magnetic base, we attach a dial indicator to the rear of the block and adjust the indicator's plunger until it rests on the end of the crankshaft. We pry the crankshaft forward until it is against the thrust surface and rotate the dial face to 0 on the indicator. To check for axial displacement, or end play, we pry the crankshaft in the opposite direction, towards the rear, and then check the indicator measurement. We at CTP are here to help and provide you the highest quality replacement parts to help keep your engine running efficiently and successfully.